Okay, let us see, let's go over this example. So we have a three-dimensional body where they're asking us to find the centroid the of this shape. Okay, and the first thing we can see is that we have, they're giving us the x, y, and z coordinate system. The origin is here. And the first thing we can see is that over y, we're going to have negative values. So be careful with the negative values. For x and y, we'll have positive values. So for our 3D shape, it's the same thing that we did for the 2D shape, except for now we'll have one more dimension, and the formulas might have a different coefficient. So the strategy will be to break these into parts where we have, and you decide how you want to do it. But in this example, they decided to have a whole plate, which is 4.5 inches long, and 2.2 inches is the width, and let's see how much, and 2 inches height. So from here to here is 2 inches. Why? Because this radius is 2 inches. Then the second body would be this quarter of a disc, and then we subtract two volumes, which are two little discs. So the same thing that we did before, we'll have to do again. Well, let's do that. 4 bodies. So one is the plate. Two is the quarter disc. And 3 and 4, we're going to subtract. 3 and 4, we're going to do disc and disc. All right, so we know that we have to find the volume. We have to find the centroid in x, the centroid in y, the centroid in z. Then we have to multiply x times the volume, y times the volume, and z times the volume. Okay, so let's create the table, because at the end we're going to find the centroid by finding x bar. So x bar times v divided by v will give us the centroid. All right, so let's start with the first object, the plate. So the plate has volume of, let's see if we can write down. So for plate, so we have volume is equal to A times B times H, which is equal to 0.5 times 2 times 4.5. Okay, 0.5 times 2 times 4.5. And that is 4.5. Yes, because 0.5 is 1/2 times 2 is 1 times 4.5. So this is equal to 4.5 cubic inches. All right, so we have the first value. All of this is in inches. This is inches to the fourth. So this is a four-dimensional object. Not object, but this is a four-dimensional unit. And then x. So in x, the half point would be at 0.5 divided by 2. 0.25. And y is 2, but we're going to in the negative axis, -1. So we have to be careful here because this unit right here is going to have a negative. So don't forget about our negative coordinate. And z, we're going to have 4.5 divided by 2, which is 2.25. All right, and let's multiply 4.5 times 2.25. 10.4.5 times 0.25. 1.12. All right. Then we have negative 1 times volume is negative 4.5. We don't even have to do this computation. It's negative 4.5 is negative 1 times the volume, which is 4.5. So we're always multiplying 4.5. And z is 4.5 times 2.25. Okay, that's the one I did before. 10.125. All right, so we got our first object. Number 2, the disk. So the disk is a little tricky. Because starting from a 0.5 in x already, remember this is x. So whatever we get, we have to add 0.5 in x. And for x, the centroid, this is x, the centroid is at 3/4 radius divided by 2. The radius is 2 inches. So 3 divided by 4 times 2 divided by p divided by pi, not by p, p is a letter, divided by pi, we get 3.8488. So in x, we get a centroid at 0.8488 to the place where our radius starts. So our circle starts right here. To that, we add 0.8488. 0.8488 plus 0.5 is 1.3488. But we actually haven't even done the volume yet. Okay, so let's do the volume. What is the volume of a quarter of a disk? So it's a cylinder divided by 4. Pi r squared times h. 1 divided by 4 times pi r h. Okay, so let's do that. R is 2, so 2 squared is 4, times h. And h, what is h? H is the thickness, is 0.5 times 1/2. 0.5 is 1/2. So this is pi over 2, which is equal to pi divided by 2 is 1.5707571. So let's go back to our table. This is 1.57. All right, we have x and y. We have the centroid in y is this 4 divided by 3 times r divided by pi is 0.8488. So this is always the centroid of half or of a quarter disk, or in this case it's 2-dimensional, so a quarter circle. This is always the centroid. And we're adding, so we have 0.8488. Except for y is negative. So I need to add a negative point, a negative sign there. Negative is because we're, again, y positive is up, y negative is down. So this is negative 0.8488. And z is pretty easy, is 0.25. 0.5 divided by 2. So 1.57 times 0, well, let's do x first. 1.57 times 1.348. 1.348. That is 211. And y is 1.57 times negative 8488. Negative 1.33. And z, we have 0. So 157 times 0.25. All right, and that is 0.3925. Okay, and then here we have the volume of object 3 and 4, which we are subtracting the volume. It's not that we have negative volumes, that we're going to subtract the volume. So the volume of that disk is, let's go ahead and do this. For disk 3 and for disk 4. Volume equals the same thing that we had before, so it's going to be the full cylinder, so we don't need the 1/4 or 1/2 or anything. It's just going to be the area times the height. So that's pi times the circle, which was 1 inch, I think. Yeah, this is actually, wait a second, it's not an, yeah, it is an inch. Let's see, is 0.5 is right here. So the radius is 0.5. So 1/2 squared times the depth, which is 0.5, which is 1/2. This is pi over 1/2 squared is 1/4 times 2 is pi over 8. And pi over 8 is 0.392. And this is a volume. There's no such thing as negative volume, at least in this world, in this earth, but we're gonna subtract. So it's negative 0. What was the value we got? 3926. All right, and obviously this is the same because they're exactly the same cylinder, the same shape. The only difference is that this shape is located at a different point. That's why we have to do both independently. All right, in X, we have, this is values that we're gonna end up multiplying and subtracting. So in X, oh, it's pretty easy. It's just 0 positive 0.25 and in X is 0.5 divided by 2, or 1/2 divided by 2 is 1/4. All right, and Y is going to be a little more interesting. It's not going to be too difficult though, because this is 0 and this is 2, so -1, right here, -1, starts from 0, and then goes to -1, and they're aligned, so it's -1 as well. Okay, now z. Z we have, this is 0.5 plus 1, correct? So this is 0.5 plus 1 is 1.5. It's positive. So for 3 is 1.5 plus 2 is 3.5, and 4 is 1.5. That 2-inch difference is right here. Okay, so the don't get confused by this. This is just basically saying that this is body 2. This is for this. This is this value right here. 4 times 2 divided by 3 pi. This is, they're looking at the shape from here. So when you have this plane, a side view, this is how you see this part. Okay, those of you who took AutoCAD modeling, you remember how do you see, this is the isometric view, and now just looking at the plane view, this is what we see. So we don't care about this part, we already have body 2 covered. Okay, and it was negative 0.8488. We have it. Okay, so x for body 3 and body 4, x is negative 0.3926 times the value, wait, that's the volume, 0.3926. We're going to subtract times 0.25. So are we going to be able to remember all that? Let's try. So negative 0.39, no we didn't, 26 times 0.25. All right, that's on the x, and this is a negative value, and we get negative 0.098. Okay, actually here we have the same value, so let's go ahead and do this one here. And y is also the same, so we should be able to compute, and is negative times negative is going to give us a positive. So negative 0.3926 times -1 is positive 0.3926, 0.3926. Okay, and we have in z, negative times positive is going to give us a negative 0.3926 times 3.5. Sorry, 3.25. Right? Yes, 3.25 is negative 127. It's negative 3926 times 3. Oh yeah, 3.5. It is 3.5. Correct. Is negative 1.37. Yeah, because it's 1.5 up to here plus 2 inches is 3.5. Got it. So this is negative 1.37 inches to the fourth, or remember this is inches times cubic inches. And then here we have times 1.5, negative 0.58. All right, so, oh man, where are we going? Let's see what that was, 37, okay. So now, in order to find x, y, and z, or the centroid in x in every point, we have to do, so if we want to find the centroid, first of all, we have a value of centroid times volume, and we have a value of, well, and we have volume also computed. Therefore, all we have to do is do summations of those values, and that will give us the centroid for x, y, and z. So let's do that. The first thing we need to do is add this. So summation of volumes is equal to negative 3926 times 2 plus 4.5 plus 1.57 is 5.2840. What was it? 5.2848. All right. Then here, summation of x volume equals 1.1.125 plus 2.11 negative 0.088 times 2 is 3.039. And this one is negative 4.5 minus 1.23 plus 2 times 0.3926, negative 5.04. Negative 5.04, and then summation of z volume is 10.125, was it? Yes, plus 0.3925 minus 1.37 minus 0.58. This is equal to 856. All right, so we have computed what we need to find the centroids. Let's compute the centroids right here. So for x, we have summation of x volume divided by summation of volume. This is equal to 3.039 divided by 5.2848. So 3.039 divided by 5.2848. 5.57, 0.575. Yeah, that makes sense because in x, well, I mean, it's not as intuitive because we have all this material right here, and we also have a bunch of material right here. So in x, 0.575. Right? Let's do y equals summation of y volume divided by summation of volume is equal to negative 5.04. Makes sense that is negative because we have the coordinate axis in negative values. So it's negative 0.95. So it makes sense because our 0 y is at the top. So every y coordinate was negative. Therefore, the centroid is going to be negative. So the y coordinate is negative 0.95, meaning that it's almost somewhere over here, almost at 1. All right, this is the key point. Where is z? Is the moment of truth? Is it going to be inside this shape or is it going to be outside the shape? It's a tough one. I wouldn't know. I want to say, well, I don't know. It's probably going to be outside. Let's see. Even though this has a lot of mass. We know that if we place this on a table, it will fall this way. So probably this way too. I think it's going to be outside. Let's see. So for z, we have summation of z volume divided by volume equals 8.56 divided by summation of volume. 8.56 is 1.62. This is 1.62. Ha! Which means in z it is outside because we have 0.5. So that point is actually somewhere over here. 0.57 at 0.95 and 1. It's like over here. So if you want to place a force, it will be outside the actual mass. So that's pretty interesting. That is the centroid of this body. Okay, so now that we found that, let's go ahead and complete this table. Now we only have to compare to our answers. So their summation of volume is 5.28. Okay, we got it. 3.048, 3.03. Okay, negative 5.47. Yep. 8.55. Yes, 8.56 we got. The centroids are at 0.57. So let's see, our centroids are inches. In y is 95 inches, 0.95 inches, and 1.62. So 0.57, yep. This is negative, as we said, negative 0.95, yep. And 1.62, yeah, they got 1.618. Okay, good. So this is how you compute the centroid in 3D for regular objects.